Hi, hello. This is Karthik S from Council Educational Info. So today I'm going to give a lecture about field astronomy, which is a module 3 in a VTU syllabus of advanced surveying subject. So generally speaking about the field astronomy, what do you mean by field astronomy? So as you can know, the word surveying, it mainly deals with the relative position of an object. So similarly, the field astronomy, it will be dealing about the relative position of the celestial bodies. So coming to the celestial bodies, we can say the celestial bodies, it is the bodies which can be considered in a space, and it can be sun, stars, asteroids and many more. So to make this particular field astronomy topic effective, I have made it as a 3 videos. One video which is this, it will be including about earth, celestial sphere, zenith and another, horizon, poles at equator, latitude and longitude and greater circle. So there are many types of greater circles. It can be vertical circle and observer's meridian, hour circle, declination circle, prime vertical. And so speaking about the earth, so as we can see, if you are standing on the terrace and watching the sky, so there will be various number of stars which will be distributed on the sky. So and these stars, it will be always distributed even if you go to any countries. So that means we can consider that our earth is surrounded by many stars which is forming a sphere. So this sphere, it is called as celestial sphere, because the word celestial, it means any heavenly bodies. Okay, so this celestial sphere, since it is forming a sphere around the earth, what will be the radius of this celestial sphere? So to determine the radius, first thing we need to determine the center of anything. So the center of the celestial sphere is taken as the center of the earth, and the radius, and if you take any one star, you can determine the radius. But if you take n number of stars, the radius, it will be varying. So we cannot give the definite value. Since for that reason, we can consider the radius of the celestial sphere as the infinite. So now speaking about the shape of the earth, the shape of the earth, it can be said as oblate sphere in shape, where the word oblate says the diameter of the earth is smaller at the poles compared to the equator, as you can see in the second picture, where at this place the diameter of the earth is very less. Okay, so now if you consider this diameter, it is more. So this length we call it as equator, and this is called as pole. As you can see the pole here, so this will be the north pole and this will be the south pole. Okay, so now coming to the direction of rotation of the earth. So earth rotates from west to east direction, but as we can see, generally the sun rises from east to west. It is like that. For example, if you're traveling in a train and if you're inside the train, you feel like you will be moving forward, but when you're inside the train, you feel like the nature or the trees around you, it will be running backward direction. So similarly, the earth always rotates in east to west, west to east direction. Okay, so now coming to the greater circle or smaller circle, since these circles are very important in speaking about the terminologies in the astronomy, we need to know about this, what is greater circle and what is small circle. So coming to the greater circle, it is a circle which divides the earth into equal halves. That is, it divides exactly at the center. That is, the center of our earth is the core. It exactly divides the earth into center. So it can divide whether in an equator portion or whether it can divide in a meridian portion or at any portion, which makes the circle at a equal half. Now speaking about the smaller circle, so this is the circle which divides the earth into unequal divisions or unequal half. So one half, it can be bigger in shape and one half, it can be smaller in shape. So that is it is a circle which divides the earth except at the center at any portion. So this is called as smaller circle. Now speaking about the nautical mile. So what do you mean by nautical mile? So as you can see, the distance which is over here in the red mark, that distance we called as nautical mile. So explaining about that, the nautical mile is the distance on the earth's surface, subtended by an angle of 1 minute from the center of the earth. Okay, so how to get the value of the 1 nautical mile? As we can know, if we consider one circumference of the earth, which is called 2 pi r. Okay, so one circumference, it always include 360-degree angle. So for one circumference, it is 360-degree angle. For 1 minute, whatever the distance we need to determine. So as we all know, the one circumference is equal to 2 pi r, and 1 nautical mile we need to determine. So for that we need the radius of the earth. So generally the radius of the earth is taken as 6370 kilometer. Okay, so substituting that 6370 kilometer, we get the value as 1.853 kilometer. So that means for 1 nautical mile, the value will be 1.853 kilometer on the surface of the earth. So now, speaking about the geographic zones on the earth, that is where the temperature of the earth will be high, where the temperature of the earth will be low. Why some of the part of the earth it will be having freezing zones, and some part it will be having higher temperature? So it mainly depends upon the angle of the sun. Where the sunlight, where it is falling more, the temperature will be high. Then where it will be high and where it will be low. So generally taking the equator here, so equator we can consider the angle as 0 degree. Okay, so if the angle is varying from 0 degree to 23.5 degree north, so this is the north pole and this is the south pole. So d 0 degree to 23.5 north, the temperature will be very high, and this is called as torrid zones. And next zone, it will be 23.5 degree north to 66.5 degree north, and this part it will be temperature will be less compared to the torrid zone, but still high compared to the other frozen zone. And this region it always called as Arctic Circle. So and this portions which is ranging from 66.5 degree north to the 90 degree, so this is called as frigid zone, where the temperature will be very less. And as you can see, the frigid zone it will be 66.5 to 90 degree, and the second comes the Arctic Circle, then comes the torrid zone. So similarly in the south direction, this is the north direction and this is the south direction. So there will be torrid zone, Tropic of Capricorn, and frigid zone, which will be at the same angle which is as above, but which is acting in minus direction, that is south means minus. So now speaking about the celestial sphere, as I explained in the beginning, celestial sphere is the imaginary sphere which is around the earth, which is enclosing many celestial objects, stars, many things. So now speaking about the zenith and nadir, so from this, whatever the definition for the particular terminologies comes, it is very important in the field astronomy, because it will be repeating again and again. So please be careful in learning it. So coming to the zenith, it is a point on the upper portion of the celestial sphere marked by the plumb line above the observer. So that means what? For example, if I am taking a point which is on the celestial sphere, which is exactly above me, that is 90 degree above me. Okay, so that point which is touching the sphere which is 90 degree above me is called as zenith, and that point which is touching downward which is 90 degree below me is called as nadir. So nadir is defined as point on the lower portion of the celestial sphere marked by the plumb bob below the observer. So this can be zenith, which is above the observer, and this can be nadir, which is below the observer. Next, speaking about the poles and equator. As you all know, the earth rotates around itself along its axis of rotation for 24 hours, and also earth revolves around the sun by taking 365 days in approx. So what is the axis of rotation? That is how the earth rotates by itself. That is, we can consider of north pole and south pole, that is this. So this is the axis of rotation of the earth, where the earth rotates around itself. Okay, so this poles It is called as one is North Pole and one is South Pole. Okay, so the equator, if you are speaking about the equator is a greater circle which is perpendicular to the North Pole and the South Pole. So the North Pole for the Earth and the South Pole for the Earth, it is called as terrestrial poles, and the equator of the Earth, it is called as terrestrial equator. So that is, terrestrial poles can be said at it is a 2 points in which the Earth's axis of rotation meets the surface. That is, Earth's axis of rotation, it is meeting the surface. And coming to the equator is a greater circle, as I said. Now moving about the celestial poles, if the Earth pole, it is projected to meet the celestial sphere. If it is projected to meet the celestial sphere, it is called as celestial poles. So this is the Earth's pole, it is projected to meet the celestial sphere. This is called as celestial North Pole, this is called as celestial South Pole. And again the Earth, it's having its own equator, and this equator, it is projected to meet the celestial sphere. And this projected greater circle in the sphere, celestial sphere, it is called as celestial equator. So celestial poles can be said as, if the Earth's axis of rotation is produced indefinitely, it will meet the celestial sphere in 2 points called celestial poles, and the equator is great circle of the celestial sphere in which it is intersected by the plane of terrestrial equator. Now speaking mainly about the great circles. So the great circle, mainly it is differentiated by what and all points it is going to join. So generally, if you see the first diagram, this first diagram mainly explains about the great circle, which is named as vertical circle, and this is named as observer's meridian. So in this is named as vertical circle, and this is named as observer's meridian. Now I will tell the difference between this both. So if the circle, the great circle, it is joining the 2 points zenith and nadar alone, that is only 2 points zenith and nadar, it is called as vertical circle. If the same vertical circle, it is joining North Pole and South Pole, both the poles, it is called as observer's meridian. So that means observer's meridian is also a vertical circle, but it is joining a 2 extra point called as North Pole and South Pole. That's all. Now speaking about the horizon or horizon, whatever you call. Now for example, if you consider the zenith and nadar for the particular observer, that is, the zenith is exactly above the observer and the nadar is exactly below the observer. So for this point, if you consider the greater circle which is perpendicular to the zenith and nadar, greater circle perpendicular to the zenith and nadar is called as the rational horizon or celestial horizon. So rational or celestial horizon, it is perpendicular to the zenith and nadar. So now speaking about the sensible horizon, for example, if you are taking the circle which is projecting from your eyes and meeting the celestial sphere, projecting your eyes and meeting the celestial sphere, or you can take any line, any circle which is parallel to the celestial horizon, but making tangential to the earth surface. It is called as sensible horizon, or sensible horizon can be defined as, it is a circle in which a plane passing through a point of observation and tangential to the earth surface. Now speaking about the visible horizon, for example, if you are in a boat in a ocean, where the ocean, you cannot see the bank of the ocean, how it will be the ocean? You can see at one end which is forming a circle, where at that circle the earth and the sky appears to meet. So that is this point, sky and earth, it appears to be meet, and it forms a circle around it like this. So this point, it is called as horizon, which is called as visible horizon. So speaking about the hour circle, it is the great circle which is meeting 2 points. Great circle which is meeting 2 points, that is, one is North Pole and another one is South Pole. So this is called as hour circle. So another thing is the declination circle. The declination circle is also a hover circle, but only it is meeting another point extra, that is celestial object. If it is meeting North Pole, South Pole and the heavenly bodies or celestial bodies, it is called as declination circle. So now speaking about the different types of angles. So first I will speak about the circle. This circle it is called as vertical circle since it passes through zenith and nadar. So this circle is called as observer's meridian since it passes through zenith, nadar as well as heavenly body. So this circle it is called as horizon. So it is passing or it is perpendicular to the zenith and nadar. Now speaking about the altitude. Altitude is the angle subtended between the horizon and the heavenly body along the observer's meridian. So angle between horizon and heavenly body. So this is called as altitude, and co-altitude is this. So this is the angle between the heavenly body and the zenith along the observer's meridian. So this angle, which is denoted as A, it is called as azimuth. So azimuth is the angle between the observer's meridian and the North Pole, which is measured along the horizon. Okay, so now speaking about the hover angle. So hover angle is the angle between this circle. What do you see? It is called as the observer's meridian. This circle is called as observer's meridian since it passes through the North Pole, South Pole as well as zenith and nadar, since it is called as observer's meridian. So angle between the observer's meridian and the declination circle till here, it is called as hover angle. It is always measured towards west. So this is east portion. So this is measured towards west. Okay. So next coming to the right ascension. So right ascensions is the angle measured from the vernal equinox or the first point of Aries. So this is vernal equinox or the first point of Aries, which I will explain later what is that. So angle between the first point of Aries till the declination circle. Till the declination circle is called as right ascension. So this is the declination circle. So declination angle is the angle measured along the declination circle from equator. So this is the equator. From the equator till the heavenly body along the declination circle is called as declination angle or just declination. That is, the declination is the angle between the celestial equator and the heavenly body along the declination circle. So now speaking about the latitude and longitude. So as we can think of the Google map, it mainly gives the position of an object based on latitude and longitude from the GPS system. That is how this latitude and longitude is obtained. So I'm going to explain it today. So mainly there are three coordinate system which is present to determine the position of an object. That is, first is geographic coordinate system, second is universal transverse mercator, that is UTM, and third is projected coordinate system. So coming to this latitude is the line which is running perpendicular to the poles or parallel to the equator. It is called as latitude, and longitude is the parallel to the poles. It is called as longitude. So the longitude, it is measured in eastward or westward direction. For example, longitude of this point, it can be said that 50 degree eastward. This point, it is called as 50 degree eastward. So this point we can take it as 60 degree westward. So always east is taken as positive and west is taken as negative. Now coming to the latitude. So latitude can be defined as, for example, if you take this point it is at a 60 degree latitude from this 0 degree to 60 degree latitude. So this point you can consider as 20 degree latitude. So to consider whatever the angles in latitude and longitude, you need a reference point. That is a reference point which is considered as 0 degree. So for longitude, the reference point is this point, that is equator. So 0 degree will be the reference point. So for example, if I take randomly what is the longitude and latitude for this point is, so as I can see, the longitude is measured in east and west direction. So for example, this is the reference point. If I measure the longitude along this direction, it will be eastward. So if I measure the longitude along this direction, this will be westward. So again, so to measure the latitude, if I measure the latitude along this direction, it will be northward, and this will be south. So to get the random position of this point it is at 40 degree longitude, and 40 degree longitude towards east, and 40 degree latitude towards north. Okay, so now coming about this line, so this line it is called as prime vertical or prime meridian. So prime meridian, it is the line which is perpendicular to the equator and passing through the place called Greenwich in the England. So that Greenwich is taken as the reference point to mark a 0 degree for to start eastward and westward. Now, so to speak about the ecliptic, so if I imagine earth is at the center and the sun is revolving around the earth, so the path made by the sun to revolve around the earth is called as ecliptic. So this is the greater circle of heavens which the sun appears to describe on the celestial with the earth as the center, and this is going to change, that is the angle of the ecliptic, it is going to change along the course. So now generally we can take this angle as 23.44 degree, and this is called as obliquity. So now speaking about the equinoctial point, so as we all know, the earth's equator and the ecliptic, it is going to meet at 2 point. So one such point is called as vernal equinox or first point of Aries, and another point is called as autumnal equinox or first point of Libra, where vernal equinox is the point where the sun's declination changes from south to north. It is changing from south to north. Here at the autumnal equinox, it is changing from north to south. So now these 2 points are the equinoctial point where the ecliptic and earth's equator it is going to meet, and solstice is the point at which the north and south declination is maximum. So at this place the declination is maximum. This is the north declination which is maximum, and this is the south declination which is maximum. Thank you.